vectors can be added and how vectors can be subtracted. So that's what I'm going to cover. Okay. So here, if I assume that A and B are two vectors which I want to add, then and C is the third vector, which is the sum of those two vectors A and B. In that I can write down C vector equals vector A plus vector B. Okay. And earlier already explained how we can now write down a vector using components of that particular vector. So for that I can write x cap A x plus y cap ay plus z cap a z. So this one it is vector A using components of that particular vector A, then plus now we have to write vector B using the components. So for that here I can write on x is x cap, then bx plus y cap, and then we have by and then plus z cap uh, bz. Okay. So if we want to add, so how we can do that? Okay. So for that means the components along the same axis are going. For example, if we have a component of vector A along x-axis and we have the component of vector B, it means the second vector along x-axis, so those two components we can add. Okay. In the same way, we can add the components of vector A and vector B along the y-axis also. So here, what I can write here like this. So x cap, then ax plus a, ax plus bx. So that's what I can write down. Then in the same way here, y cap, we can write ay plus by and then plus z cap a z plus bz. So in this form, in this way we can add these two vectors. Okay. And graphically how we can represent. So now you can see if we have a vector A, so now you see this is vector A, and the second vector we have inside somewhere anywhere. So for example, this one it is vector B. Okay. And this is vector A. So in the space we can shift vectors. Okay. So that's what means. The condition is that the direction should be same, means whatever it was the direction. For example, whatever the direction, the same direction and the same magnitude if we keep as it is, then in that case we can move these vectors on the plane. So now if I move this vector here, so now here we have second vector B, and if you want to add these two, so how we can add? So two rules are there. So the first rule here, that is a parallelogram rule. So the sum of these two factors, how we can do. For example, here again we can draw a parallelogram. Is parallel to this vector B. Here one vector and parallel to this one another one. So if I do like this, so this one A, so this one also become A. So like that here you have this one. Okay, and this is your vector C. Okay. Graphically, this is the way how we can represent. And the second rule here it is. So this is parallelogram. So this one we can say this one it is. This is parallelogram rule. And the second rule, that is head to tail rule. That is head to tail rule. It means simply you are going to shift this vector A to the head of this vector B, and then now you are going to use the third vector which is going to join. Let me first draw this one. So this is vector B. So this is the head, and the tail of Now here what I'm doing, so this vector I'm shifting to the right side. So if I shift, so then the tail of this vector A will come in contact with the head of vector B. And if these two means head of B vector and tail of A vector if going to come in contact with each other, so that in that way we can add these two, and the vector, the third vector which is from the tail of vector B and to the head of vector A, so that vector will represent vector C. Okay, so this is the graphical way to visualize how vectors can be added. Okay, so there are applications of such visual way to represent vectors and to analyze vectors, manipulate vectors in different ways. So that's why we use. Okay, so this one it is known as a head to tail rule. Okay, this is head to tail rule. So this one it is about the addition. Okay, in the same way, if we want to subtract, so then subtraction it is nothing but simply if you change the, you can say you can use the direction of the vector in just opposite to whatever it was earlier. So and then after adding those two vectors, so that it will give the same result as if as if those two vectors were subtracted. Okay, so I will show you how. So I think this is clear. Now the third vector I am taking, which is third vector A vector minus B vector. Okay, that's what I want to do. So this one I can write like this: A vector plus, and then after what I'm doing here, minus B vector. So minus B vector meaning the magnitude, if it is going to remain the same, only the direction it is going to change. So that's what it is happening here. So now what you can do, simply you can write vector A here by using the components of that particular vector along three axes, means along x-axis, y-axis and z-axis. So here I'm using x cap, then ax plus y cap ay, and then z cap az. So this one it is a vector A, then here, and if it is written minus b vector, it means wherever it is plus, just like x cap written, so there I can put minus. If I put minus, it means that it is representing only the direction. It means the change in the direction only, not the magnitude. So magnitude will remain as it is. There will be no change in the magnitude, only the direction will change. So that's what I'm going to do here by using the components of that particular vector. So here we have in the component form. So here I can write down minus x cap and then bx, then after minus here because minus b vector I am taking. So here I can write like this, and that's it is. So this is the way. Okay, so here I'm adding, but due to the presence of that minus sign, so these two vectors are going to be subtracted. Okay, so I'm using the concept of addition, but here due to the presence of this minus, which is representing the direction, is opposite to whatever it was the earlier direction, so here subtraction we will get. So here we can write x cap ax minus bx, and then plus y cap ay minus by, and then plus z cap, and then here we have a z minus b z. So that's it is. I think that it is clear. In the same way, we can do many things with vector analysis. It is very powerful. So now next here we have the position and distance vectors. Position and distance vectors. So I think I can paste this. Yes. Here, position and distance vectors. And one thing keep in your mind that whatever mathematical tools I'm going to explain you, it means whatever mathematics in different subjects, I will explain you that how those mathematical calculation can be used practically, because I I believe in practicals, because here I am explaining things by keeping the perspective of engineering. So that's why, because I think if we can apply the knowledge of science, means whatever scientific knowledge we have, so if we can apply to solve the problems of the real world, so that's what we uh, do. It means what engineers do. So that's why here I will explain you in detail, means whatever subject I will explain you that why mathematics is very important for understanding and analyzing and manipulating different things. Okay, so that's why I think this mathematics is one of the most beautiful subjects. So that's why here you have position and distance vector. So again I'm going to draw the graph. Okay, if I make this one a little bit bigger, then it will be better. Now you have this one, it is x, y, z. Now next I'm going to take 2 points. Okay, 2 points I'm going to take. For example, the first point here I'm taking, the second point I'm taking somewhere around here. Okay, these are 2 points. So the first point I am taking the name P1, and the second point I am taking P2. Okay, and the coordinates of these 2 points, because here I'm sorry, because here I'm using Cartesian coordinate system. So according to that things I'm representing. Okay, when I will use other coordinate system, then accordingly I will change the way to represent different points. Okay. So you are familiar with the Cartesian coordinate system, so that's why in the beginning I'm explaining using this system, and later on I will use spherical coordinates or and cylindrical also. Okay, but here for simplicity, so that you can understand in a better way, because you are, I think most of you are familiar with such things. Without, so that's why I'm explaining this. So now this unit is the origin, and the vector which is joining this point P, okay, the vector which is joining this point P, that is nothing but R1. Okay, I'm giving the name R1, and then this second one I can join the second point, so that it is R2, and the third one here, the joining point P1 and P2. I will explain you, no need to worry about that, what different things I'm writing. I will explain. So the coordinates of P1 I can write down x1, y1, and z1. Okay. And in the same way, the coordinates of P2, x2, y2, and z2. So now you see how we are getting this one. So simply if you draw a projection, okay, on the xy plane, then you will get the values just like here. So this one it is, what it is? This one it is y1 and this one it is x1. In the same way, if you draw a projection from this point to the z-axis, then you will get, okay. So now you can see here the perpendicular, these all are perpendiculars. So this one you will get z1, clear? In the same way, if you draw a projection on the xy plane, then you will get the value of x2 and y2. For example, if I draw a projection from here to the xy plane, now here if you are getting, then in this case also, if you join, okay, now here and let me see. So here you will get the value of x2 and this is value of y2. In the same way, if you draw a projection on the z-axis, then here, so again these are perpendiculars, so don't confuse about this. So these all are perpendicular. So now here you will get value of z2, okay. So now x2 y2 z2, so here x2 y2 z2. So these distances means from here to here, whatever is the distance, so along x-axis, that is x2. So whatever the distance from origin to y2, that is value of y2 in here, and whatever is the distance from origin to this z2, that is here z2 in this. So how we represent? So here r1. So r1, you can say this, that is a vector. That r1 is the position vector for point p1, and r2 is the position vector for point p2, and r12. Okay, r12, that is the distance vector. Okay, the distance in between p1 and p2 is represented by the vector r12. Okay, so how we can represent it by using the components of that particular vector along different axes. So that's what I'm going to write. So here first r1 I'm going to represent. So r1 vector that I can write down. R1 here you have OP1. Okay, because from origin to P1, so that's what I can write down. OP1 vector, and then that it is equal to, by using the components I can write x cap, then the value of x1 with the whatever it is the distance, you can say this value where it is x1, yes, this OX1, so that's it is x1, then y cap, then y1, and plus z cap, and then we have z1. Okay, that is, now you see r1 is the position vector for point p1, means this r1 is representing the position of the point p1 in the coordinate system, or you can see in the space. And in the same way here r2 we have here it was op1, and now r2 it is representing the position of second point in the space, so that's I can write down op2, and for this one x cap, then we have x2, y cap, y2 plus z cap, z2. Okay, so these two are position vectors only, and now we have to find, so now that's why here heading written position and distance vector. So these two are position vectors, so that's what I explained here, okay, using the components. Okay, now you can see here clearly, so x cap x2, so x cap x, x cap meaning, so whatever it is the unit vector, so now you can see unit for example if it is x cap, okay, and then here you have y cap, here you can write on y cap, in the same way here z cap. It means along these three different axes, so what are unit vectors, so those things are represented by these x cap, y cap, and z caps. And now next position vector r12. Okay, so position vector r12, that we can write down p1 to p2. It means the direction of the vector, it is from p1 to p2. Okay, so p1 to p2 means this p2 minus or you can say R2. So R2 vector minus R1. R2 vector minus R1. That we can write here. Okay. And here again, by using the components along these three different axes, you can get. So how we can write using the components? So R2 here you have, so x cap x2 plus y cap y2 plus z cap z2. Okay, minus, and then the second, sorry, R1 vector, and that is the position vector of point P1. So that we can write x cap x1 plus y cap y1 and z cap z1. Okay, and simply you can take x1, sorry, x cap, then x2 minus x1, then y cap, then y2 minus y1, then plus here you have z cap, and then z2 minus z1. This one is R12 vector. It means this is the distance vector, and the magnitude distance vector means this R12 is representing this. Okay, R1 is representing to this, R2 representing this one. Now next what we can do, we can find out the magnitude. So okay, since I have already explained the formula how you can find the magnitude of a particular vector. So here that we can get R12 simply because I already told, if I don't write this arrow symbol at the top of any vector, then in that, sorry, any letter, it means that it is representing the magnitude of them. So this one I can write square root here, x2 minus x1 whole square now this one here, this one gives the magnitude of distance vector. Okay, so this is distance vector, which is representing the distance in between point P1 and P2, and this one, it is the position vector of P1. So here if I write down, then it will be better. Position vector. So these two are position vectors. Okay. I think here clear. Next one, I will explain you factor multiplication. So what different kinds of factor multiplication which we use in factor analysis. So that's I will explain you next.